Hi, everybody. As promised, I want to give you all a bit of a demonstration with how to use R to actually do analysis on real data. And for those that weren't able to make it to section, this is essentially what I was hoping to do at the end of section, but due to internet issues, was not able to do. Okay, so what you're looking at here is called RStudio, and as I think I've mentioned a few times before, it's basically a local version of Jupyter Notebook. So rather than Jupyter Notebook, which I run in the cloud or in a web browser like you all do, this is RStudio, and it runs directly on my machine at home. So first thing I'm going to do is I'm going to load up these two libraries, and libraries again are basically extensions to base R. So after you download R, you download these libraries, and they give you kind of additional tools and different things that you can do with data. So we're going to focus today on data on the English Premier League, which is a soccer league in England. And we're basically going to do a couple of different analyses with this soccer data. So first things first is I'm going to run this this line of code here, EPL 2018-19. And what this read CSV over here is going to do is it's going to basically ingest or upload a CSV file. And CSV, of course, just stands for comma separated values file, which is a format of data that you'll find online a lot. So once I've run this line of code here, I can now learn a little bit about my data. And so as you all have seen before, there's kind of a few main functions that you want to use to learn about your data. The kind of the first one that you'll see is str, which stands for structure. And that definitely gives me a good overview of the data, right? As I can look here and I can see that I have 380 observations of 62 variables. And if I go down this list here, I can see what each of those different variables is called. I can see what kind of variable it is, and I can see kind of the first values that come up, right? So some of them are pretty intuitive, right? Is like something like home team, right? Shows me that for this home team variable, I can have values of Man United, which stands for Manchester United, which of course is a soccer team. I have Bournemouth, Fulham, Huddersfield, right? Ditto for away team, right? That's just the team that plays on the away side of any given game. And I have Leicester, Cardiff, Crystal Palace, and so on. Referee also makes a lot of sense, right? I assume that these are the names of the referees at the different games, but a lot of these are actually pretty hard to, for me at least, to interpret, right? So, you know, HS, AS, AF, HY, all these different variables, I could come up with a pretty good guess just based on my own soccer knowledge as to what it is. But if I was new to soccer and I was looking to learn more about it, it would be pretty tough to use this data. And indeed, this isn't just a situation in which I've downloaded a bunch of data that doesn't have very well labeled variables, but which I could learn more about by, for example, downloading a code book. There was not a code book for me to observe with this particular data set when I retrieved it from the internet. And so indeed, if I use glimpse, for example, if I use the glimpse function, I've got kind of a pretty similar overview that I got from structure, right? With just more of these values actually popping up, and head will actually give you the, again, you all know what head does, is it gives you the first few rows of a data set, but the story is kind of similar, is that this data set has some really good stuff here, but for many of the variables that they're kind of unclearly labeled, and so as a result of that, I'm not exactly sure what to do with this information. The reason I highlight this is because you will often be in this situation where you're looking for data, you find something, you download it, and it's not quite what you were looking for. This is like a very real world situation, so I just kind of wanted to model that a little bit for you. What you can do in those situations when you're stuck and the data that you have aren't great is you can find a different data source. And so what I've actually done here is I've found a different data source on English Premier League soccer, right? On stats related to these soccer games in England. and I've downloaded it, but rather than download it as a CSV, which I've done here, the place that I found this data from allowed me to download it as an RDA file, where RDA just stands for R data. Basically, it's a specific file format that captures data for R only. So, for example, you wouldn't be able to use this in other statistical programming environments. And so, because this is an RDA file rather than a CSV file, the way that I actually load this data is using a different function called load rather than read CSV. So instead of read CSV, I'm going to go ahead and run this line here. That's actually going to load this whole big thing called England EPL data ing, soc soc data, right? Missing an R there. So yeah, and so if I and so once I load that, I don't actually specify the name of the data frame here. I'm told that, or rather, the way that I find out what the data is actually called is by looking down here in something called environment, which would look again a little bit different in the Jupyter notebook. But I see basically that when I ran that load function, that I was given something called England, and so what I understand that to be is that England is the name of the data frame that was created from the data that I loaded. And I can run the same functions, right? I can run str, which again stands for structure. I can run glimpse, and both of these will give me some intuition about the data. Str tells me that there are something like 200,000 observations here across 12 variables. And what's nice about this data is that the variables are very clearly named, right? Home, visitor, division, and tier. These are all sort of English words that I can understand. And indeed, something like H goal and V goal, right? Just based on having these home and visitor variables, and of course some intuition about English Premier League soccer, I can intuit what these variables stand for, which is of course home goal and visitor goal. So now, having loaded some better data, I can actually answer some questions. For example, who has played the most games in EPL history? And it's worth mentioning that this England data frame that I've been looking at is historic data across all of EPL or English Premier League soccer history. One way I can do that is by running this chunk here, which I will explain to you in a second. But I first wanted to show that this is what I get. This is the kind of thing that you might see. So again, this is a kind of data frame, right? It's similar to the ones that we've looked at in class so far. But what it shows me is that Preston North End, right, has been the home team in 2,503 EPL games going back to 18 something. Notts County has been in many games as well. It's been in 2,493 games. Burnley is kind of third, and so on and so forth. And indeed, each of these 144 rows here will be an individual team that is played in the EPL as a home team. And this column for each of these rows will tell me how many games they've played in over time. And I can do that for how many times each team has been a visiting team as well. And unsurprisingly, they're going to be remarkably similar if you remember the values for this field on the home team or on the home field rather. The reason for this being that teams in the EPL play a roughly even number of home and visitor games in a season. Okay, what's actually going on here? This is some code that uses so-called pipes. So this symbol here, which is just percent, greater than sign percent, is called a pipe in our language, PIPE pipe. And what basically is going on here is that each argument on the each sort of object that I've written in R on the left side of a pipe is being piped into the argument on the right side. And so one other way to read this would be for me to have actually written all of these on the same line, which I think gives you maybe a bit more intuition, where basically what's happening is England is being piped into group by home, which is being piped into tally, which is being piped into arrange descending n. The reason I write my code in this way is because I could in theory want to write additional arguments, and so that would be something like this, and it just makes it easier for me to keep track of everything. But all of that aside, what's actually happening here is I'm taking my data frame, right, called England, and then I'm doing something called group by home, which is this sort of bread and butter procedure that you'll see in other programming languages as well, like SQL and others that you might encounter that do any kind of database or data frame type operations. But the bottom line is that it's going to be aggregating, right? It's going to be combining all the different rows for a given home team, right? So something like, again, going back to our actual output on this, it's gonna combine all the different rows for Preston North End, Notts County, Burnley, and so on. Each time that one of these teams appears in the home field, right? So every time that Preston North End appears as the home team in this data frame, it's gonna sort of mash all those rows together, and then it's gonna spit out the number of times that team appears, because I've then asked it to pipe into tally. And then last but not least, this last line, all it's doing is it's arranging, right? So arrange is another name for sort, which you all have seen in course kata. And it's going to arrange descending, which means that the largest number is going to appear at the top, and the smallest number is going to appear at the bottom. And it's going to do this descending arrange by n, which of course is the number of observations, the number of times that each team appears as the home team here or as a visiting team here. And so this is interesting, right? For me, I now know which teams have played the most home games in EPL history. But I actually want to do something a little bit more. And so what I want to do is I want to ask this sort of very basic question. I just made an argument that teams play roughly the same number of home games as they do away games in a season, but that may not be 100% true, right? And so I want to make sure that that's the case. How I'm going to do that is actually by combining data frames and then doing something called mutate, which is going to create a new variable that I'm going to write as the share of games that have been played at home versus away, and then look at the value of that measure. First things first is I want to take these two data frames that I've created here, right? One for home games and one for away games, which take this shape that I've already specified here, and actually combine them. And so what I'm going to do is I'm going to do my same data frame group by tally sort of sequence here, but then rather than have home, right? Rather than have this variable be called home, and rather than have the sort of corresponding variable in the visitor data frame be called visitor, I'm just going to rename all of those to the variable name team. And rather than have the count of actual games played be the variable name n, I'm going to have it be count home in one case and count away in the other case. And the reason for this, so let's run these two lines of code real quick. We can actually take a look, and I can show you that. Let's, for example, take the head of this data frame here, which is just called count home games. And you can see that it's got the same sort of form as I showed you before. It's of course not arranged, which I don't care about right now. But now, again, it's the same information, but the team appears under the variable name team, and the number of home games that they've played appears under the variable name count home. Count away games has the exact same structure, except of course it's going to be representing visitor games instead of home games. But what I'm going to do now is sort of take these two data frames that I've created, count home games, count away games, and on this variable team, right, which of course indicates the team that has some number of home and some number of away games. I'm going to basically it's called joining. I'm going to do an inner join, but I'm basically going to sort of splice them together like this, right? So I've got count home games here, which has team name and then some number of games played, and then I've got count away here, which has team name and some number of away games played. and I'm going to join them together like this, which will produce a kind of a third and different data frame as its output, right? And what that data frame is going to have is team name, number of home games, and number of away games in one data frame rather than two. So actually running that bit of code and then pulling in the head on that, you can see the result of that here, right? So now rather than have two different data frames, I've got team name, number of home games played, and number of away games played. Again, of course, across history. So Aberdare Athletic has played exactly 126 home games and exactly 126 away games. Going back to my question of whether teams basically play the same number of home games as they do away games, it seems like that the answer is probably going to be yes, just looking at the fact that a lot of these are either exactly the same, right, even in larger numbers, or are pretty dang close. But still, I might want to do a bit more of a diligent check for this. And so the way I would do this is to go back up right here, and this again is just the line of code that I ran to get the output that you just saw, which is the head of this new games total data frame. And so what I want to do here is show you how to actually create new variables, right? So of course, going back down here, I showed you that I've got these two variables or columns in my data frame, the number of home games and the number of away games. But what I'm actually going to do here is create three new ones. The way I do that is by this syntax here, where I say this new data frame that I'm creating is called games total. It's the same name as the one that I'm sort of working from. So I'm adding things onto a data frame and then just saving it basically with that same name. Just like if you work in a Word doc and you write some words, you would save it with the same name, but it would be a different version. The way that I actually create the new variables is using this function mutate. So if you remember the pipe, I'm basically taking my original data frame that has two variables, right? This one here. I'm piping it or passing it to mutate, which is the function for creating new variables. And then here I'm actually specifying those variables. So the first one is going to be called count total. It's going to be the sum of of home games and away games. And then I'm going to create two additional variables that are very, very simple. One is share home, which is the share of all games played that are played at home for any given team. And then count away is going to be the share of all games played for any given team that are played away, right? So where they're the visiting team, basically. And so I can just run this bit of code here, right, which is just this chunk here that I just ran, and I can take the head on that again, and voila, I've got all my different variables here, right? So I've got from the original join, right, that I did. I've got the number of home games. I've got the number of away games. I now have the total number of games, right? So 126 plus 126 gives me 252. 61 plus 61 gives me 122, so on and so forth. And then I've got these two variables here, right, that are share home and share away. And again, that's just for share home, that's this number over this number. And for share away, it's this number over this number. And so going back to my question of do teams actually, how much does the share of home games vary across teams, or basically do teams actually play the same number of home games as they do away games? If that were 100% true 100% of the time, share home would be equal to share away. They would be literally the same number as they are, for example, for Aberdare Athletic, and as they are, for example, for Accrington FC. But they're not always exactly the same. For example, Accrington Stanley and Accrington are not exactly the same. Neither is AFC Wimbledon, for example. And so, clearly the answer to the question of do they play the exact same number of home games and away games every year, for all teams, the answer to that is no. But still, I probably might assume that those are going to be comparable, and I can actually look to see whether that's the case by running this this bit of code here and getting a distribution. So I will actually not spend too much time talking about how I actually get the result here. what I'd rather do is actually spend a little bit of time talking about this here. So you all remember we talked about distributions, we talked about histograms versus density plots. This is an example of a density plot. And what it's doing is it's plotting the distribution of this variable share home, where the x-axis, of course, is the value of the share of games across history for a given team that are played at home, right? And then the y-axis is the density of that, so the relative sort of share of all possible values for this x variable that hit any particular point, right? So this is sort of the relative share of observations that are right at 0.5, and this is the relative share right here, for example, of this 400 corresponds to something like 4.995 or something, right? Something very close to 0.5. So without getting too caught up in the weeds, the main takeaway is that right at 0.5, right at the value of share home that suggests that teams play half their games at home and half their games away, right here is where like the lion's share, right, the huge sort of portion of my overall mass, of my overall distribution, sits right at this 50-50 mark. And so that pretty much confirms for me, right, even across, and this of course is the distribution across all teams, across all history. It gives me a pretty compelling answer of yes, basically, teams play the same number of home games as away games. Okay, probably not anything earth-shattering, but I think still gives you some intuition behind how you can use some of these functions. We might be interested in a more, I think, substantively interesting question, which is, do teams actually score more at home versus away? And the way that I'm going to do that is through a series of different functions here. One is going to leverage something called summarize. And so if you look at this chunk of code here, you'll see that it's fairly similar to what we were doing with tally earlier. It's still leveraging these pipes. But what it's doing is it's taking the England data frame, it's grouping again by home, for example. So this is going to again sort of aggregate or smash down all the rows for which home takes a value of any given team, AFC, Accrington, or whatever we were saying. And now what it's going to do is for each distinct value of home, right? Not for every time that AFC Accrington appears, but for the one distinct value of AFC Accrington, I'm going to actually create a variable. But rather than using mutate, I'm going to use summarize because I'm creating it at this aggregated level, right? So summarize allows me to first mash up all the rows and then create a new variable that I'm going to call average home goals, but which will actually be generated with this code, which is mean of h goal, and so h goal is a variable for my original data frame. I'm going to take the mean, right? So the simple average of this variable, and I'm going to pass that simple average to the variable name average home goals, and I'm going to produce this, right? And so rather than even save this data frame, I'm just spitting it out directly by running these 3 lines of code. And again, that was sort of a lot of words to say that what you now have is a data frame containing all 144 teams that have ever played in the EPL in history. And what you have in this average home goals column is the average number of goals that they score at home per game. So Aberdare Athletics scores an average of 1.79 goals per game. Accrington scores an average of 1.54 goals per game. Accrington FC is a little better. They score just over 2. AFC Wimbledon is pretty bad, right? They only score 1.28 goals. So again, just another way to look at this data that might be a little bit more interesting. But so we haven't quite answered this question of, do they score more goals at home or away, because we're only looking at this sort of version of this analysis that groups by home and looks at the average home goals. Of course, you can imagine that we could sort of replicate this for average away, and we could replace this with away, and we could we could sort of write away in here. But what I'm going to do is instead is sort of do all that here. So again, this line, for example, takes this code, writes it in a single line, and then just renames this home variable to team as we did earlier. This line does the exact same thing, but for basically replacing home with visitor and replacing average home goals with average visitor goals, right? Except that I'm calling them average away goals just to sort of trim down the number of characters. And once I've created these two data frames, right, which are of course going to have the same form as what I'm showing you down here, I'm going to join them together again, right? I'm gonna do this join that I was talking about earlier, combining both data frames on the unique team name variable. So I'm going to take the average home goals, average away goals, put them together, and so each team will have both of those variables. I can actually just show you that as well. So running that bit of code there will give me this. And just as I was saying, right, I've got the number of I've got the team name here, which is just a particular value of this team variable. I've got the average number of home goals here. I've got the average number of away goals. And even just looking at these first 10 rows, you can see that I already have some intuition for my hypothesis, right? Or for my answer to the question, really. So, Aberdare athletic scores like almost a full goal more at home than away. Accrington is a little closer. They score just about half a goal more on average. Accrington FC is a little bit more than half. And then like Accrington Stanley already gets back to just about one more goal at home versus away. That's even more so the case with Ashington, for example, that scores more than one full goal more at home versus away. So again, this is a helpful look across the first 10 rows, but it's not quite comprehensive. I'm not able to see across my entire data frame. I could of course do that and look across all the different rows. You're probably telling me, Igor, don't do that. You can just you can do group by summarize and kind of do different kinds of aggregate level statistics that you all have done in course kata. But one other thing that you can do is you can actually visualize this as well using this ggplot package. And so again, I'm not going to spend too much time describing how the actual syntax of the code works. But what you can do is you can just very easily visualize. And so I just want to point out that in this plot that I'm about to show you, the blue line corresponds to the average number of home goals, and the which you can see here, and the green line corresponds to the average number of away goals. And so what this distribution shows is that they are, of course, different. And so what you can see immediately is that the distribution of the number of away goals in this green color here is concentrated close to 1, just a little bit past 1, right? There's this huge concentration of mass here. The blue one, of course, is concentrated quite a bit further, right? It's concentrated closer to 2, not quite at 2, but indeed it's got a different distribution as well, right? It's not quite as peaked here, right, as the green one is. It's got these wider tails, so on and so forth. And so of course the takeaway from this is that on average teams score more of these blue home goals than they do of these green away goals, which of course is the answer to our question of here of do teams score more at home than they do away. I would like to close, right, and so that's basically it. I would like to close by giving you 2 prompts that I would like you, if you're watching this video, great job. What I would like you to do now, once you have a little bit of time, is in a discussion forum that on a thread that I'm going to create, respond with one of the 2 following things. Tell me either what is the difference between the 2 distributions, between the blue and the green distribution that I showed you over here. So you can tell me that, or you can give me 1 or 2 sentences at most, so no more than 1 or 2 sentences, just describing what this code chunk here is doing. So the one that's actually generating this graph here. So again, I'm going to create a thread on the discussion forum. For those that have seen the video, tell me either the difference between the blue and the green distributions using some of the language that you have from Course Kata, or explain to me in 1 or 2 sentences what the code or how the code that generates those distributions actually works. Great. That's it. Thanks for watching the video. Hopefully this was helpful. If you have any questions, please let me know, and I look forward to seeing you in class.